Hello, in this video we're going to talk about how to find parallel and perpendicular slopes given an equation. So as we're getting started out, our problem we're going to start with asks us to determine the slope of the original line, then to find the slope of a line parallel and perpendicular to that original line. So I have three examples and they're all in slope-intercept because this is one of the easier ways to find it. For point slope, it would be the same thing because we're given slope in those equations. And so to get started, the first thing that I would need to do is I would need to identify slope. So all of these equations follow the form y equals mx plus b. And I know they follow the form y equals mx plus b because when I'm looking at my three equations, they all say y equals. So what I'm going to do is I'm going to look at the number in front of my x, that coefficient that's usually a fraction, and those are going to be my original slopes. So my first line, my slope is going to equal 1/3. In my second equation, my slope is going to equal -2/5. And in my third equation, slope is going to equal 8. Okay, so then to find the slope of a parallel line. Parallel lines are lines that never cross. They look like railroad tracks. The way that we get a line that is parallel is that the slope is the same, it just has a different y-intercept in this case. So for all of these, the slope of our parallel lines are just going to be the slope that we just found. So for my first equation, the slope of a line that is parallel to y is equal to 1/3 x minus 3 is 1/3. If they were different, eventually those lines would cross, so we need them to be the same. In my second equation, the slope of a line parallel to y equals -2/5 x plus 8 is -2/5. And the same for the third one. Those slopes are the same. Now, the more interesting one is perpendicular. Perpendicular lines are lines that cross at 90-degree intersection. The slope of a perpendicular line is the opposite reciprocal. So what that means, in this case, opposite means we flip the sign. If it was positive, now it's negative. If it was negative, now it's positive. And then the reciprocal is the fraction being flipped. So as we go through these, you're going to see what I mean. So for our first one, and I'm going to do this in steps, the opposite of 1/3 is -1/3. And then the reciprocal, I'm going to take the number in the denominator and put it in the numerator. I'm going to take the number in the numerator and put it in the denominator. For the fraction 1/3, the reciprocal of that is 3/1. Our opposite reciprocal, or the slope of a perpendicular line to y equals 1/3 x minus 3, is -3/1. Okay, for our second equation, I go through the same process. The opposite of -2/5 is positive. And then what I'm going to do, the number that is in the numerator goes to the denominator. Number in the denominator goes to the numerator. The opposite reciprocal of -2/5 is 5/2. And then finally, for our last line, 8x plus 3, sorry. The opposite is negative. Now the fraction 8 can be written as 8/1. So when I flip my fraction, this becomes -1/8. So if we are given an equation in slope-intercept form or point-slope form where we're immediately given slope, to write or to find the slope that is parallel to that, we keep it the same, and perpendicular is the opposite reciprocal. Now, let's talk about what happens if we're not given it in slope-intercept form. The only other form that we can be given this in is standard form. And I said only other because, again, if it's in point-slope form, we're still given the slope. So with standard form, nothing that standard form gives us is useful for what we're trying to do. We need to convert this to a different form. So the options we have for what we convert standard form to is slope-intercept and point-slope. Now, we can't convert it to point-slope because we don't know the specific point that our line is going through. I mean, we could find one, but that'd be more work. So what we're going to do is we're going to convert this to slope-intercept. The phrase we're going to keep in our head is we're going to solve that equation for y. We are going to manipulate this equation so that we have y equals at the very end. As I talk about this is going to sound more like rearranging an equation. This is going to sound more like a literal equation than it is what we're doing at this moment, because those things are the same. I'm going to erase this to give myself some room, and then we're going to go through this. Okay, so when I am trying to solve for y, what I want to get rid of is this 3x and this coefficient. So what I'm going to do first is I'm going to look at my 3x. I see that I have positive 3x, so I'm going to do the opposite. I'm going to subtract 3x from both sides of my equation. On the left-hand side, the 3x's cancel out, and what I'm going to be left with is 8y is equal to negative 3x plus 32. Now, you are going to notice, before it didn't matter. We would just write 32 minus 3x, or, what I have currently. You want to put the x term first because, again, floating in the background, we want this to look like slope-intercept form. So I am putting the x thing first, right? I'm just taking that and dropping it down. And then I'm saying, oh, I had a positive 32. Well, look, there's positive 32. Okay, the next thing I would do is I'm going to divide everything by 8. Before, we just drew a line and said, hey, everything gets divided by 8. Because again, I don't know why I wrote B there. Again, we want our equation to be in slope-intercept form. So what I'm going to do is instead of just having one giant division bar, I'm going to divide this by 8, and I'm going to divide this piece by 8. What that does is I'll be given y. For the fraction, or for the division of negative 3x divided by 8, all I am going to do is turn that into a fraction. I'm going to write this as negative 3 over 8 x, and then 32 divided by 8 is 4. So notice all I've done is use my inverse operations twice. How I've written it looks a little bit different, but it's also that I have this equation in slope-intercept form when I'm done. Now I can look at this and go, oh, hey, the original slope is negative 3 over 8. If I had a slope for a parallel line, I'll just do that. That's going to be the same. It's going to be negative 3 over 8. the slope of a perpendicular line will be the opposite reciprocal. So now that's going from negative to positive, and I flip my fraction. Once I've converted out of standard form to slope-intercept, then it's much faster to do or to find the slopes of the different types of lines. For my second example, again, I have another one here so that we can see how we're converting out of standard form. It's going to sound the same. I see that I have negative 2x, so I'm going to do the opposite, which is adding 2x to both sides of the equation. Again, I'm going to put the x thing first and then the 28 second. I'm going to divide everything by 7. I'm going to rewrite this division as a fraction. And 28 divided by 7 is 4. So after I've done my inverse operations twice, after I've solved this equation for y, what I'm going to say is, hey, my original slope is 2/7. The slope of a line that is parallel to this is the opposite, the slope of the line that's parallel to this is the same, so this would also be 2/7. And then my slope of the line that is perpendicular to this is the opposite reciprocal. So I go from positive to negative, and I flip my fraction. Here are some quick examples for how we determine a slope of a parallel and perpendicular line given some original equation. If you still have questions, please be sure to reach out, but otherwise, that's how you solve these problems.